A 15% voltage drop on a branch circuit downstream of a ground fault circuit interrupter, GFCI, is a cause for concern. There are several reasons for this. Firstly, overheating can occur. Excessive voltage drop can cause wires and devices to overheat due to increased resistance in the circuit. This overheating can potentially lead to electrical fires. Secondly, there is the aspect of reduced performance. Appliances and other equipment connected to the branch circuit may not perform optimally with such a significant voltage drop. Thirdly, code violations are possible. The National Electrical Code (NEC) allows for a maximum voltage drop of 5% on branch circuits. A 15% drop exceeds this limit and could potentially violate electrical code requirements. Fourthly, it presents a safety hazard. Faulty wiring caused by voltage drop can pose a safety risk to occupants of the building. Now let's consider the possible causes of such a voltage drop. One possible cause is loose connections. Another possible cause is undersized wires. A third possible cause is excessive load on the circuit. And lastly, a significant distance from the electrical pile can contribute to voltage drop. So what should you do in this situation? Firstly, contact a qualified electrician. It's important to have a professional electrician diagnose the issue and determine the root cause of the voltage drop. They can then recommend and implement appropriate repairs. Secondly, reduce the load on the circuit. Unplug or redistribute appliances and other devices that may be drawing too much power from that particular circuit. Thirdly, check the connections. Inspect all electrical connections, including those in outlets, switches, and the electrical panel itself. Tighten any loose connections that you find. Lastly, consider upgrading the wiring. If the wires are undersized for the load and the length of the circuit, the electrician may recommend upgrading them to a larger size. This would help to reduce resistance and consequently the voltage drop. Ignoring a significant voltage drop like this can lead to serious consequences, as we discussed earlier. Therefore, it's always better to err on the side of caution and have the issue properly diagnosed and resolved promptly by a qualified professional. When an electrician assesses the voltage drop, they'll likely use a multimeter to measure the voltage at different points along the circuit. This will help them pinpoint where the voltage drop is most significant. They'll also inspect the wiring for any signs of damage or corrosion, which can contribute to increased resistance. In addition to checking for loose connections, the electrician will also examine the quality of the connections themselves. Poorly made connections can also cause resistance and voltage drop. If the electrician determines that the wiring is undersized, they'll recommend replacing it with a larger gauge wire. The appropriate wire size depends on the amperage of the circuit and the length of the run. The NEC provides tables that specify the minimum wire size for various circuit ratings and lengths. When upgrading the wiring, it's important to use the correct type of wire for the application. For example, non-metallic sheath cable, often referred to as Romex, is commonly used for residential wiring. However, other types of wiring, such as conduit and individual conductors, may be required in certain situations. The electrician will also ensure that the new wiring is properly grounded. Grounding is an essential safety feature that helps to protect against electrical shock. In addition to addressing the voltage drop itself, the electrician may also recommend other safety measures. For example, they may suggest installing arc fault circuit interrupters of size, which can help to prevent electrical fires caused by arcing faults. They may also recommend upgrading the electrical panel if it's outdated or insufficient for the home's electrical need. When dealing with electrical issues, it's always best to rely on the expertise of a qualified electrician. Electricity can be dangerous, and it's important to take all necessary precautions to ensure your safety and the safety of your home. Remember, the 5% voltage drop recommended by the NEC is a guideline to ensure efficient and safe operation of electrical equipment. Exceeding this limit can have detrimental effects on the performance and lifespan of appliances and other devices connected to the circuit. A 15% voltage drop is a significant deviation from this guideline and warrants immediate attention. In addition to the potential for overheating and electrical fires, excessive voltage drop can also lead to premature failure of electrical components. Appliances and other devices are designed to operate within a specific voltage range. When the voltage drops below this range, the device may have to work harder to perform its intended function, which can lead to increased wear and tear and ultimately, failure. For example, a motor operating at a reduced voltage will draw more current to maintain its speed. This increased current can cause the motor to overheat and eventually burn out. Similarly, electronic devices may malfunction or fail altogether if the voltage drops too low. Therefore, addressing a significant voltage drop is not only a matter of safety but also a matter of protecting your investment in electrical appliances and equipment. When the electrician investigates the voltage drop, they'll also consider the possibility of shared neutrals. In some older homes, multiple circuits may share a single neutral wire. This can lead to overloading of the neutral wire, which can cause voltage drop and other problems. If the electrician suspects a shared neutral, they'll use specialized testing equipment to verify the wiring configuration and correct any issues. It's also important to note that voltage drop can be more pronounced when multiple devices are operating on the same circuit simultaneously. This is because each device draws current, which contributes to the overall load on the circuit. Therefore, it's important to avoid overloading circuits by plugging too many devices into the same outlet or using extension cords to power multiple devices from a single outlet. In summary, a 15% voltage drop on a branch circuit downstream of a GFCI is a serious issue that should not be ignored. It can lead to overheating, reduced appliance performance, code violations, and safety hazards. The best course of action is to contact a qualified electrician to diagnose the cause of the voltage drop and implement appropriate repairs. In addition to addressing the voltage drop, the electrician can also identify and correct any other electrical issues that may be present, ensuring the safety and reliability of your home's electrical system. Remember, electrical safety is paramount, and it's always better to err on the side of caution when dealing with electrical issues. The NEC also specifies requirements for the size of conductors based on the type of insulation used. Different types of insulation have different temperature ratings which affect the amount of current the conductor can safely carry. The electrician will ensure that the conductors are properly insulated and sized according to the NEC requirements. When the electrician is checking connections, they'll also look for signs of corrosion. Corrosion can increase the resistance of connections and contribute to voltage drop. If corrosion is present, the electrician will clean or replace the affected component. They may also apply a corrosion inhibitor to prevent future corrosion. In addition to checking the wiring and connections, the electrician will also inspect the circuit breaker or fuse protecting the circuit. A faulty circuit breaker or fuse can also contribute to voltage drop. The electrician will test the circuit breaker or fuse to ensure that it's functioning properly and replace it if necessary. It's also important to ensure that the electrical panel is properly grounded. The grounding system provides a path for fault current to flow back to the source, which helps to protect against electrical shock. The electrician will inspect the grounding system to ensure that it's properly installed and connected. They may also perform a ground resistance test to verify the effectiveness of the grounding system. If the home has aluminum wiring, it's especially important to have a qualified electrician inspect the wiring. Aluminum wiring is more prone to corrosion and loosening than copper wiring, which can lead to voltage drop and other problems. The electrician may recommend replacing the aluminum wiring with copper wiring or installing specialized connectors designed for use with aluminum wiring. It's also important to educate yourself about electrical safety. Learn how to identify potential electrical hazards and take steps to prevent them. For example, avoid overloading circuits, use extension cords safely, and never attempt to repair electrical equipment yourself unless you're qualified to do so. If you're planning any electrical work in your home, it's important to obtain the necessary permits from your local building department. This will ensure that the work is performed according to code and that it's inspected by a qualified electrical inspector. Finally, remember that electrical safety is an ongoing process. Regularly inspect your home's electrical system for any signs of damage or deterioration and have any problems corrected promptly. By taking these steps, you can help to ensure the safety and reliability of your home's electrical system. The NEC provides detailed guidelines for electrical installations, including requirements for voltage drop, wire sizing, grounding, and overcurrent protection. It's important to follow these guidelines to ensure the safety and reliability of your electrical system. The electrician will be familiar with the NEC requirements and will ensure that all work is performed according to code. When the electrician is investigating the voltage drop, they may also use a thermal imaging camera to identify hot spots in the wiring. Hot spots are areas where the wiring is overheating, which can be a sign of a loose connection or other problem. The thermal imaging camera can help the electrician to pinpoint the source of the overheating and take corrective action. It's also important to ensure that all electrical outlets and switches are properly installed and functioning correctly. Damaged or faulty outlets and switches can pose a safety hazard and should be replaced immediately. When replacing outlets and switches, be sure to use the correct type for the application. For example, ground fault circuit interrupter. GFCI outlet should be used in wet locations such as bathrooms and kitchens to protect against electrical shock. It's also important to ensure that all light fixtures are properly installed and wired. Loose or damaged light fixtures can pose a fire hazard and should be repaired or replaced immediately. When replacing light fixtures, be sure to use the correct wattage bulb for the fixture. Using a bulb that is too high wattage can overheat the fixture and cause a fire. In addition to addressing the voltage drop and other electrical issues, the electrician may also recommend energy-saving measures. For example, they may suggest installing energy-efficient lighting, such as LED bulbs, or upgrading to more efficient appliances. By taking these measures, you can reduce your energy consumption and save money on your electricity bill.